Hello everyone. In this video, I will go over section 1.4, which is identities. Identities is just a fancy way to say that two things are equal. Okay. So before we go over the reciprocal identities, which we technically talked about this already, let me refresh your memory on something that we did before. So recall that you have a triangle, which for lack of a better name, I'm just gonna call this one A, B, and C. The sine of theta was defined to be as A over B. And then cosecant, notice cosecant of theta is the reciprocal, which is B over A, okay? But notice that if we do 1 over A over B, this is exactly the same thing as B over A. So this is what these identities are referring to. They're called reciprocal. These are the easiest of all the identities you will see, because you know one, you just flip it and you get the other one. So notice that if cosecant is 1 over sine, this implies that sine theta is 1 over cosecant. And this also implies, this is very important, that you multiply therefore sine theta times cosecant theta, that you will get 1. That's going to be the case for this one and for this one. So therefore, if secant is 1 over cosine, that means the cosine theta is 1 over secant. Okay? Also, if cotangent is 1 over tangent, that means that tangent is 1 over cotangent, and so forth. So therefore, the main purpose of these reciprocal identities is the following. For example, let's say that I tell you the tangent of theta is equals to 3/5. So therefore, that implies automatically that cotangent theta is 5 over 3. Or let's say the secant theta is equals to 3. So notice that 3 is the same thing as 3 over 1. So that means the cosine theta will be 1 over 3, and so forth. So for example, if sine of theta is minus 1 over 7, that implies that cosecant theta is minus 7 over 1, and so forth. Now, just a side note to make life easier, it is very important that you see the relationship between the identities, but you can always get all of these values also from the triangle, so you should start getting used to doing triangles like this, like the original one, because this is going to make life very simple, and I'll show you this in the next few examples. Now, the next set of identities is called ratio identities. We're also going to use this a lot. So again, if you have a triangle, let's say this is obviously a right triangle, this is A, this is B, and this is C. So notice the sine, let's say this is theta. The sine of theta is A over C. Again, the opposite over the hypotenuse. And tangent, not tangent, cosine of theta is equals to B over C. And also the tangent theta is equals to A over B, okay? But notice what happens here. If you divide sine theta over cosine theta, this will mean that you have A over C divided by B over C. And remember, when you divide fractions, you have to flip or multiply with a reciprocal. So this should be A over C times C over B. And notice that this cancel. So this is important, notice this. And from here, you can see that this equals to a over b. But a over b is exactly the definition of tangent. So therefore, the first ratio identity is the following, that tangent of theta is the same thing as sine of theta over cosine theta. So this is important, you should memorize this. Now, in the previous page, we saw the reciprocal identities. And remember that cotangent of theta was equals to 1 over tangent, or the reciprocal. So therefore, if we use that, if you do the reciprocal of this, that means therefore the cotangent is just cosine theta over sine theta. And you should also memorize this. So for example, let's say that they give you this. They tell you the, so example, say that they tell you the sine of theta is equals to 1 over radical phi, and cosine of theta is equals to 2 over radical phi. And they ask you to use these two, sine and cosine, to find tangent of theta. So the example should be find tangent of theta with the given information. So therefore, from here, remember the tangent of theta is the same thing as sine theta over cosine theta. So therefore, this should be 1 over radical phi divided by 2 over radical phi. Notice that the radical phi is cancelled, so therefore tangent will be 1 over 2. Remember that a few minutes ago I told you can just always verify this with triangles. So for example, this is what I mean. Notice here that if this is theta, and you either use this one or this one, it's telling you that this is 1, this is radical phi, and this is 2. So notice if you create the triangle first, obviously tangent is the opposite, which is 1, over the adjacent, which is 2, and you get the exact same answer. But for now, it's very important that you do it this way, because you're going to need this a lot in chapter 5 especially. So let's do one more example of that. Let's say the sine theta is equals to 3 over radical 10, and cosine of theta is equals to 1 over radical 10. All right, so then the question is going to be find cotangent of theta. Notice that this part or this information is always given, okay? So this is what's given to you. They will tell you if this is true, if this is given, find this. So same thing here. So remember that cotangent is the same thing as cosine over sine. So in our case, this will be cosine is 1 over radical 10, and sine is 3 over radical 10. The radical 10s cancel. This is 1 over 3. Now, why do they cancel? Because you have 1 over radical 10 times radical 10 over 3. Because when you divide, you have to flip the reciprocal. This cancels. And you end up with 1 over 3. Again, you can also just do a triangle like this one in here, and you'll see you get the exact same answer. For example, this is 1, this is 3, that's what they give you. This radical 10, you can see that tangent is 3 over 1, so therefore cotangent is 1 over 3. All right, the last type of identities we're going to focus on, they're called Pythagorean identities. These are the 3 identities that you need to memorize. You should definitely memorize these three identities. I'm going to show you right now how to derive them, but you don't need to know how to derive them. You just need to memorize them. So again, if this is 90 degrees and this is theta, and you call this A, B, and C, according to the Pythagorean theorem, this is why these are called Pythagorean identities. Remember, A squared plus B squared equals to C squared. So let's look to case number 1, because you have 3 formulas. So you look to case number 1, this is what we're going to do. Let's divide both sides by C squared. So you do that. Notice that you can rewrite this as A over C squared plus B over C squared equals to 1. But remember that A over C is the definition of sine. So this is sine squared. So again, this is the definition of sine. And then B over C is the definition of cosine. So therefore, this and this is equals to 1. So this is how you get the first equation. In a similar way, you will get the rest. You don't need to know how to derive it. You just need to memorize them. So you need to memorize this, and that. Now, the thing that's going to be more useful besides memorizing these three identities is you need to be able to recognize when they are written in a different way. So, for example, if you have you have sine square plus cosine square equals to 1, notice that this is the exact same thing as saying cosine squared theta is equals to 1 minus sine squared theta. Or sine squared theta is equals to 1 minus cosine squared theta. They are exactly the same thing. Also notice that from here, sine theta, if you take the square root, is the same thing as this. So therefore, even though this is what you need to memorize, you need to understand that this, and this is exactly the same thing. And it's very, very similar to this. So for example, if 1 plus tangent square is equals to secant square, this is definitely what you should memorize. It's going to be very useful sometimes to say that 1 is equals to just secant square theta minus tangent square theta. So notice that if you move this to the side, you get this. Similar for this one. You can see from here the 1 will be equals to cosecant square theta minus cotangent square theta, and so forth. From here, you could also say that cotangent square theta is cosecant square theta minus 1, and even the cotangent theta is the square root of cosecant square theta minus 1, and so forth. Okay? So again, the important thing, and this takes a while to get used to, is you should memorize this first, but understand that this, the same thing as this, the same thing as this, and the same thing as this. You should memorize this. We need to notice that this and this are the exact same thing. And for this one, this and these are the same, and this is the same thing as this, which is the same thing as this. I know it's a lot at the beginning, but it's not too bad. If you start memorizing them right now, it will make your life easier. You're going to use this hundreds and not thousands of times between now and the end of the class, and also if you take calculus 1, calculus 2, and so forth. All right, so let's see how we use these identities to solve problems. Here they tell you find sine of theta if cosine theta is 5/13 and theta is in the 4th quadrant. Okay. So now I'm going to show you how to do this with identities, and then I'll show you also a slightly easier way to check your answer using the triangle, which is something you technically already did. So for example, here, we already know the sine square plus cosine squared is equals to 1, which is this identity right here. Now, since you want sine, remember that this was equivalent to this, okay? So therefore, you just had to rewrite it that way. And from here, you can just say, okay, well, sine squared theta is equals to 1 minus cosine squared theta. So therefore, sine squared theta will be 1 minus 5 over 13 squared. So this is equals to 1 minus 25 over 169. If you multiply 25 times 5 is 25, 13 times 13 is 169. Now, if you simplify this, notice that this will give you 169. The LCD is 169. 169 times 1 is 169. So essentially, this is what you have. You have sine squared theta instead of 1. 1 is the same thing as just 169 over 169. Okay, so that's not a tricky question. You should check on that. This is equals to that. The only reason why we did that is because you want to combine it with the other part. So this will be minus 25 over 169. And this is 144 over 169. So therefore, from here, that means the sine squared theta, it will be 144 over 169. And then you take the square root. Now, since this is on the 4 quadrant, remember we did this before, all students take calculus. If we're in the 4 quadrant, the only one that is positive there is cosine. So that means sines will be negative. So this will be minus the square root of 144 over 169. So this will be minus 12 over 13. And that will be the answer. Now notice, and this is just to verify your answer, it may be much easier to solve these problems if you just do a triangle. This will be a problem very similar to the ones we did in the previous sections. So cosine, you have theta, and cosine is 5 over 13. That means this is 5. This is 13. And if you use the Pythagorean term, this is 12. So clearly, sine is just 12 over 13, which is exactly what we got here. Remember, the reason why it's negative is because this is on the 4 quadrant. So the triangle can make things easier to verify. So you can always do this to verify your answer. If the question says use identities, you had to do it this way. But there's nothing that says, you have to do it this way. But there is nothing that says that you cannot use the triangle to check your answers. And that's actually even going to be the case for the next problem. You'll see. All right, so in this problem, they tell you that sine theta is equals to 1/2. Theta is on the second quadrant. And you need to find the remaining using identities, okay? So there is many ways to do this problem. So if sine theta is equals to 1/2, that implies that cosecant theta is equals to 2 over 1 using the reciprocal identities, okay? And therefore, remember that you have an identity, a Pythagorean identity that says the following. The 1 plus cotangent square is equals to cosecant squared theta. So therefore, if we use this identity, we'll have the 1 plus cotangent squared theta should be cosecant squared. But cosecant is 2, so therefore it should be 2 squared. So therefore that means cotangent squared theta plus 1 should be equals to 4, which means cotangent squared theta should be equals to 3. Now, since we're in the second quadrant, cotangent is going to be negative. And notice from here that cotangent theta will be negative the square root of 3. Now, so we found one here, so 2. Since cotangent is radical 3, we can use another reciprocal identity. And remember the tangent is equals to 1 over cotangent. So in this case, it will be minus 1 over radical 3. And now we have 3 of them. Now to find cosine, you can use the first identity, which was this one. And once you find cosine, you can find secant. Or we can use this one, since we already know what tangent is, to find secant first and then find cosine. So let's actually do that. So remember the identity we have is that 1 plus tangent square is equals to secant square. But we already know what tangent is. Tangent is minus 1 over radical 3 squared. And from here, you can start from secant. So notice that you have 1 plus 1 over 3 equals to secant squared theta. If you add these two, the LCD is 3, so 3 plus 1 is 4. So you will have 4 over 3 is equals to secant squared theta. Then secant is going to be the square root. Since we're in the second quadrant, right, that's what it says. Secant, remember, is negative there. So it's going to be negative the square root of 4 over 3, which this will be minus 2 over radical 3. So therefore, from here, that means that cosine theta is equals to minus radical 3 over 2. And that will give us the six answers we need. Now, I told you can check all your work with a triangle. So let's do that. So let me check the solution. So let's say check and see that everything matches. So this is what I mean by checking. So the thing that they give you, it was the theta, sine of theta is 1/2, and you were on the second quadrant, okay? So if this is theta, this is 1, this is 2. This is actually one of the special triangles. It has to be radical 3 by using the Pythagorean term, okay? So use the Pythagorean term and you will get this. But let's just verify this. So see, cosine should be radical 3 over 2, which is exactly what we got. Negative because it's on the second quadrant. So if this is the case, then it has to be the case. And notice that tangent is this over this, which also gives you the answer. Okay, so you should check your answers using the triangle just to be sure. And that's it. All right, let's do one more example. Let's say that they tell you that tangent of theta is equals to 5 over 3, and theta is on the first quadrant. So remember, in the first quadrant, everything is positive. And let's say you want to find the rest of the trigonometric functions. So from here, you automatically know that cotangent theta is going to be 3 over 5. So that's the first one. Then remember that 1 plus tangent squared theta is equals to secant squared theta. This is one of the Pythagorean identities. So therefore, 1 plus 5 over 3 squared should be secant squared theta. So therefore, 1 plus 25 nines should be secant squared theta. If you find the LCD is 9, so 9 plus 25, notice it's 34 over 9. And therefore, secant theta is going to be the square root of 34 over 3, because the square root of 9 is 3. So therefore, you now know secant. If you know secant, that means you know cosine. And cosine is going to be 3 over radical 34. Again, remember the reason why everything is positive is because we're in the first quadrant. And then from here, once you know cosine, you can use the identity to find sine. Remember, the first one was sine squared theta plus cosine squared theta equals to 1. So therefore we have sine squared theta plus 3 over radical 34 squared should be 9, which means sine squared plus 9 over 34 is equals to 1, or sine squared theta will be 1 minus 9 over 34. And then you find the LCD is 34, so 34 minus 9 is 25. You should check on that. And then you take the square root, sine of theta will be 5 over the square root of 34, because you have the square roots. So if you know sine, then you automatically know cosecant, which is the reciprocal, and that should give you this, and that's the answer to the 6th. Now, like I told you already a couple times, it's a lot easier to find these values with a triangle, but it's very, very important that you know how to use these identities, because they're going to be crucial later. But you can always use the triangle just to check. So again, this is telling you that tangent, this is the original information, is 5 over 3. So therefore this is 5, this is 3. If you use the Pythagorean theorem, this is going to be 34. You can verify everything from here. So notice that sine is the opposite or the hypotenuse, which is this. Cosine is this over this. And you can see it's much faster to just use a triangle to check your answers. Okay, so use the triangle to check. And that's it.